Hello everyone, welcome. This is the turbine jet engine, a machine design that operates based on Newton's third law. Simply put, this mechanism utilizes the reaction force similar to air expelled from a balloon, providing its thrust. Just like a jet engine in an airplane, what propels the aircraft forward is the reaction force produced by the high-speed jet engine at the tail of the jet engine. Therefore, it's clear. The higher the speed of the air expelled from the turbine, the greater the thrust. And it's this thrust that enables the plane to fly and move forward. That's roughly how the principle works. However, as we know, most jet-powered aircraft use the turbofan design, so we will focus on this particular model here, considering that jet engines come in a wide variety of designs. A turbofan is a collection of high-tech propellers within a channel known as a diffuser, manipulated and powered by a gas generator. To clarify, let's break down this component by component. The core. The core of a jet engine is the gas generator that supplies high-pressure gas fuel to drive the turbine. This system includes the compressor, combustor, or combustion chamber, and turbine. Let's first focus on the compressor part. Compressor. The compressor in a jet engine operates by drawing air from the atmosphere and forcibly compressing it into a progressively smaller space. Each compressor stage consists of a rotating rotor paired with a series of stationary stator blades affixed to the core casing. The rotor's role is to draw in atmospheric air, while the stator blades are designed to slow the incoming airflow and prevent backflow, thus increasing air pressure. Typically, a compressor will have multiple low and high pressure stages to achieve the necessary compression ratio, depending on the engine's design and technology. Now, let's move on to the combustor section. The combustor. In the combustor section of a jet engine, air is mixed with fuel and ignited as it passes through, with the fuel supply releasing a powerful gas stream. The design showcased here is an annular combustor, meaning it is ring-shaped. The compressed air enters through intake nozzles, each coupled with a fuel injector designed to distribute the fuel-air mixture evenly. Ignition devices, similar to those in car engines, ignite the mixture. Once ignited, combustion continues as air and fuel are supplied, much like a household gas stove. The turbine. Let's move to the rear. The turbine at the back of the jet engine is powered by exhaust gases from the combustor. Most of the turbine's power is used to spin the turbine fan, with a small percentage driving the compressor. It's worth noting that the turbine fan gets extremely hot. This issue is mitigated by diverting some air from the compressor to aid in cooling, along with special coatings on the surfaces and a specially designed turbine fan to prevent direct contact with the hot gases, keeping temperatures under control. Exhaust cone. At the rear, we find the exhaust cone, specially shaped to mix and accelerate exhaust streams. Its working principle is similar to slightly closing a hose nozzle to increase output pressure. This part also serves to protect sensitive internal engine components. The fan. Originally, jet engines were turbojets, which directed all incoming air through the core. Most modern aircraft engines have evolved into turbofans, where only a portion of the incoming air is directed into the core or gas generator. This design allows part of the generated power to drive specially designed fans at the front. These fans, high-tech propellers within a duct, work by splitting incoming air into two paths, one into the engine core and the other bypassing the core, which is called bypass air. High bypass engines are designed for moving large amounts of air at slower cruising speeds, aiming for better efficiency. Moreover, the exhaust gas speed is a major factor in jet engine noise. Still, high bypass engines encase the fast-moving core exhaust with slower bypass air, resulting in quieter operation. Hence, these engines are often used in commercial or large military transport aircraft capable of carrying heavy loads. However, military fighter jets use low bypass engines, which are more compact, have a high power-to-weight ratio, and have the capability for supersonic speeds and afterburners, but at the cost of higher noise levels and fuel consumption. Afterburner. High-performance jet engines often feature afterburners, which inject extra fuel into the jet pipe to mix with exhaust gases and ignite, creating a second combustion stage. Due to their fuel inefficiency, afterburners are typically used briefly during takeoff, ascent, or combat maneuvers. And that's the information we can share in this video. What are your thoughts on this type of engine? Do you think there will be more advanced aviation engines beyond turbines? We'd love to hear your opinions in the comment section below.